performance that stakeholders expect.
Stages of system development. The stages. First, elicitation of cradle to grave functional requirements from the stakeholders. Second, definition of a system concept that satisfies to the lifelong requirements. Third, successive functional modulation of the system concept. Fourth, physical integration of components to build the system. An airplane consists advanced materials, highly performance engines, onboard computers, navigation and communication systems, and more. The development project of being alone involves some 4,000 engineers with desperate expertise from many companies just to coordinate their efforts is a major management task for the system engineers. They are also responsible for assembling experts in many areas, organizing them into cohesive multidisciplinary teams, integrating their knowledge and bringing them to the bear on the project. The philosopher Martin Heidegger once contemplated Van Gogh's painting of a pair pheasant shoe and saw the meaning of human existence. Use and readiness to hand also shine in engineered systems. Systems engineering mixes technological development with a long-term strategic management planning. Engineers have been among the leaders in strategic management since the rise of large-scale industry and mega enterprises. They established modern corporate administration in 19th century and still hold many top executive positions today. System engineering seeks to clarify, justify, and establish optimum managerial practices, particularly in high technology fields. So, what is system engineering? It is a combination of technology development with strategic management. In our time, they have technological improvements like machines and so on. System engineering creates a highly technology that can help us. It is originated in the Cold War and was revitalized in 1980s when American industry faced stiff commercial competition from Japan. The Japanese, especially Toyota Motors, are experts in system engineering. So, American analyzed Japanese practices and incorporated many of their innovation into system engineering. The abstraction of general principle from one culture and apply it appropriately in another culture is a mark of scientific thinking which transcends a narrow cultural bonds. In system engineering, American and Japanese are based on my research in system engineering, American and the Japanese are the most experts here in system engineering. American and Japanese have a competition and said that Toyota Motors came from Japanese are truly expert in about system engineering. Functional abstraction and system theories. System engineering, which sits at the crossroads of engineering and management, it unmistakably practical and down to earth. Systems theories, on the other hand, which are the heart of engineering research, are the mathematical and very abstract. This is not to say that system theories are useless. They are all in general useful. The concept of function through which system theories are applied to specific designs connect them to the system engineering. Adam Smith said whose Wealth of Nation appeared in the same year as his friend Walt Steam's engine observed a relation between machine and abstract system. System in many respects resemble machine. A machine is a little system created to perform as well to connect together in reality. Those different movements and effects which are the artist's occasion. For a system is imaginary machine invented to connect together in fancy those different movements and effects which are already in reality. Performed. Smith's remark adumbrated the abstraction for concrete machineries prevalent in engineering system theories. Some characteristics of a systems theory. Functionality. The theory is for the sake of reliable communication. Abstraction. The theory idealizes from physical properties. Generality. The theory is concerned not with particular communication system but with general principles underlying all kinds of reliable communication system. Mathematical representation. The functional relation among the communication components are represented in mathematical terms. Abstraction should be idealized from the physical properties. Generality. The general principles underlying all kinds of reliable communication systems. Mathematical representation. The function relation among communication components are presented should be in a mathematical terms in engineering system.